Earlier they get that experience of, oh, this is something I can do, and actually it's incredibly useful, the better in terms of shaping their ability to engage with STEM later. But the scope is endless.
Hi there, and welcome to the Pondering Dan podcast, where we talk all things teaching, education, pedagogy and technology. I'm your host, Danny Summerall, and if you're new to the show, make sure you leave a review and share with your peers. Connect with me on Twitter, Instagram and YouTube at Pondering Dan, as well as at ponderingdan.com. My guest this week is Dr. Linda McIver from Australian Data Science Education Institute, otherwise known as ADSE. Linda started out as an academic with a PhD in computer science education. When it became apparent that high school teaching was a lot more fun, Linda began a highly successful career at John Monash Science School, where she built innovative courses in computational and data science for Year 10 and Year 11 students. Nominated one of the inaugural Superstars of STEM in 2017, Linda is passionate about creating authentic project experiences to motivate all students to become technologically and data literate. While Linda loves the classroom, it was rapidly becoming clear that teachers in the Australian school system were keen to embrace data science, but that there was a serious lack of resources to support that. That's why Linda created ADSE to support data science in education. You can find ADSE on Twitter at DataSciAU, and you can find Linda at Linda McIver. Linda, thank you so much for joining me on the podcast today. I've been to a number of your workshops over the last couple of years, and I always learn so much from you. So I was beyond excited that you agreed to be this week's guest.
Thanks, Dan. I'm really excited to be here.
Yeah, excellent. So can you start off just telling us a little bit about ADSE?
So the goal in setting up ADSE, as you said, was to get data science into the classroom. So we do that by training teachers and by developing lesson plans and project plans to try to take the effort out of it for teachers so they can just grab something and run with it instead of having to develop whole new curriculum, which is what I had to do when I started teaching data science.
Excellent. And so you started it to support data science in Australian schools. So what was the catalyst for you to change things?
So there was sort of a long, slow process that really changed my thinking. And what happened was when I started teaching at John Monash, I had a Year 11 computer science course, which was really an area where I had complete freedom. And we did computational science projects where we worked with scientists to meet their data needs, basically. So the kids were writing real software that had the potential to have real impact. Of course, it didn't always. It was a school project, some were more successful than others, but there were never any guarantees. But the kids got to work on something real. So the data was messy and it was complicated and they had to learn about the domain in order to make it work. It was really authentic learning. And I saw so many of those project groups go on and continue working on the project the next year, even though there was, no credit in it anymore, but they could see that it was useful and they wanted to keep going because they were just so motivated by it. Yeah. And I had one student come to me who wasn't doing my computer science course saying, please, will you let me do the assignment? I don't know how his other teachers felt about that, but I mean, you can't turn that down, can you?
No, that's amazing.
So it was clear that I had something special with those projects. At the same time, when I started at that school, we were teaching a Year 10 computer science subject where we were teaching programming using toys. They were doing Scratch-based things in a system developed by Monash called Scribble, which was for drawing pretty pictures.
Okay.
And there was another one called Cellular, which was for doing simulations. And although we were teaching sort of real concepts, we were doing it with toys and there was nothing authentic about it, nothing where the kids could see the point of this. And the single most common bit of feedback I got was, why are you making me do this? Okay. This isn't relevant to me. I don't want to do this and it's nothing I'm ever going to use. Okay. And it didn't matter how often we argued that you people are science students, you're going to need to code. They were like, yeah, but we're not going to need this. And you couldn't argue with that. They were never going to use Scratch for anything real. Yeah. So I had one student who he's my cautionary tale and he knows I tell this story. I have his full permission. But he was in year 10 sullen and uncooperative. He already knew a bit of tech, he knew a bit of code, and he didn't want to play with these kids' toys. And so he was really difficult. And I had a lot of sympathy for him because I didn't like the course any more than he did. But we got on each other's nerves because I couldn't get a stitch of work out of him. And, I was trying to do my job as you do. Even when you're teaching something you don't like, you've still got to do the best you can. So then I saw him signed up for my year 11 course and I was just so annoyed. I was like, oh God, why would you do this to me? You don't like me any more than I like you. Just go away. It's all about me, of course. And then the very first lesson, we started learning a bit of Python in the context of artificial intelligence, and the kids were supposed to be writing a chatbot. And this kid went home and he wrote a perfect English to Pig Latin translator.
Wow.
Overnight. Came back with 1,000 lines of code, and I broke it on Qantas, which is cheating, and Rhythm, which is not. And he went back and he fixed that. And then he started to make it more modular, and he commented his code, and it was just astounding. Yeah. And I looked at him and I went, where have you been? And it was just that I had given him something real to do. And he went on to team up with another couple of students. They did one of the best projects I've ever seen. He wrote documentation for it. He wrote a problem specification, which is one of the most professional I've seen, and that's including industry.
Yeah.
Just extraordinary because he could see the point.
Yeah.
And for me, that was a real turning point because it made it very clear to me that we were never going to engage the kids who didn't think this was relevant with stuff that actually wasn't relevant, And I mean, that's not rocket science, but we try to do that a lot in teaching. We go, here is this math stuff to learn. We're not going to give you any context for it or why you need to know it or, give you anything it's useful for, but you're going to have to learn it.
So they were solving real problems.
Yeah. As soon as you give them real problems to solve, they can see the point and then they go nuts.
Yeah.
So eventually I managed to persuade the school to switch to data science in year 10, and all of a sudden the kids were engaged, and I was not getting the why are you making me do this, it's not relevant to me anymore. I was getting, this is so useful and I'm using it here and I'm using it there, and it's, like I've used it in maths and I've used it in geography, and they could see the point.
Yeah.
It completely changed their attitude to the relevance. It changed the output. They were massively engaged, and that's why I quit.
There you go.
Because I thought, everybody needs the opportunity to do these kind of projects. But to do data science in school is actually, for the teachers, it's a lot of work because you've got to find an interesting data set. You've got to then make sense of it, which is sometimes really difficult. And then you've got to build a project around it. And the only reason I was able to do that was that I was half-time.
Yeah.
So I used my own time to build those projects, and it was totally worth it. But a teacher who's full-time doesn't have that wiggle room to play with.
That's right.
So I figured that if I could write up these kinds of projects and give them to teachers in a form where they can just grab it and run with it, then that was going to change things.
Yeah. So talking about those real-world problems, obviously that's important for kids these days. Is that why you think data science is so important in education?
It's a combined effort, really. The real-world problems is massively important, and data science is a really nice way to do that. And it also gives amazing scope for differentiation. So you can do a project where the kids who've never coded before and think they can't do it can do really simple data cleaning projects like removing duplicates, and it's still useful, it's still on real data, but they've got a really simple 5 lines of Python and they've achieved something. And then you've got the advanced kids who are using crazy analysis and visualization packages and machine learning, and they can go for their lives. But the other aspect is that we all really need to understand data. Data science is increasingly running the world. We have machine learning algorithms that are controlling healthcare and traffic and finance, and nobody understands them at all. We don't even know the impact of using Facebook on our behavior, and it is much bigger than we think it is.
Absolutely
so
right.
If we don't have a population which has an understanding of data science, then the population has no say in how the future is designed.
Yeah.
And make no mistake, data science is designing the future. So we all need an education on that so that we can say, hang on a minute, I'm not sure that's a good idea.
Yeah. No, that's a really good point. And I'd never thought of that myself. But having a think about, obviously, with a lot of the work you've done has been secondary school, and I'll be completely honest, it's way over my head, and I'm not a master programmer, and I'm not a data scientist. I'm a primary trained educator, and I know we've talked in the past a little bit about how we can bring valuable data science into, say, a primary setting, where a lot of our data might be simple things like how many kids in the classroom have brown hair or blonde hair and blue eyes or brown eyes. And it's very basic and it's not solving problems. So I guess that my question is, like, what would good data science look like, say, for primary school?
Primary school projects are my favorite because they give the kids an opportunity to have an impact in their own community. By the time we get the kids to high school, they've usually decided that they can't do STEM, that it's too hard for them, or it's too complicated, or it's too nerdy, or they don't like it. So the earlier they get that experience of, this is something I can do, and actually it's incredibly useful, the better in terms of shaping their ability to engage with STEM later. But the scope is endless. So I've got projects for primary school around advertising. So this is a grade 3-4 project that I'm just in the middle of finishing up, which is count the ads that you see in the world.
Yeah.
Interesting. And then, combine that data as a class and, do things like predict how many ads do you think you see in a week? And then actually how many ads did you see? And might you have missed any of the ads? So all that rich complexity of, is this data actually perfect? Well, no, because no data is ever perfect, But then also going, well, what kind of ads did you see? And do you think they had any impact on you? And that's data science, but it's also social sciences, and it's also, civics, and it has links right across the curriculum, and you can be doing maths with it. We're not writing any code, but it's still data science.
And it's interesting when you look at some data science projects, especially for primary school, how broad the links are across every strand. Yep. Literacy, numeracy, civics and citizenship, humanities, it's all there. Yeah. So as they get into secondary, obviously they're able to look at problems a lot deeper, a bit like what you've talked about before. Have you got a good example of some good problems that kids have used data science to solve in secondary?
One of the first ones I ever ran in high school, I ran with year 10s, and it was on the electoral data.
Okay.
So we went to the AEC website and we downloaded all of the votes for the Senate for Victoria for the federal election, and then we analysed that. So it was over 3 million lines of data in a CSV file, so basically a spreadsheet file. But Excel won't even open a file that size, so they had to code. But we had kids writing, as little as 5 or 10 lines of really simple Python that just grabbed the data they wanted out of that file and then kind of did some things with it. And then what we had them do was create their visualizations by hand. And that's actually a really powerful technique. That there are very few visualization packages, in fact, I haven't found any, that really allow you to do really creative and compelling visualizations.
Okay.
So you do the graph in something like Excel, but then you make it compelling by hand. So you use the Excel version to give you the scale and you make sure that it's accurate, but then you do something creative with it. So that data had so much potential because each line in that file was a vote. Okay. It was one person's vote. And the Senate ballot paper is massive. Has that particular one had 151 boxes on it. And there was a space on each line for sort of each box. So you could say, well, if someone voted number 1 for the Greens, who did they vote number 2 for? And you could use that, sort of do that across all 3 million lines of data. And we had kids go, okay, where did Pauline Hanson voters come from? Were they urban or rural or inner city? We had kids look at the female candidates below the line and figure out what percentage of the votes they got compared to the male candidates below the line. We had people look at which party's voters were more likely to follow the how to vote card, I loved that one.
Yeah,
so every kid found a different aspect of the data to look at. Was the same data, and most of them wrote code that was very, very similar, but none of it was the same.
Yeah.
So, it deals with plagiarism. It kind of knocks everything on the head. It just makes, in many ways, makes it really easy because you're working with the same data set. It's all the same skills, but kids are coming at it from different angles.
Yeah. It's a lot of work going into that.
Yeah.
Sounds amazing.
It took a lot to set it up. And that was one of the really sort of key things that made me go, yeah, somebody needs to support this. And so when I decided I needed to get this to a wider audience, I looked around, I thought, I'm going to find who's doing it and I'll join them and we'll make this happen. And I'm like, who's doing this? Hello? Anybody? Crickets.
And so then it was you.
Okay, I guess I'm doing it.
Yeah. It's really interesting when you talk about the problems and looking at the data from the AEC, and, even you can be surprised with the sorts of things that students are going to be looking up. You might have your own vision, but at the end of the day, they're still going to find things that you might not have thought of, which is amazing in itself.
That's the beauty of it. And it's kind of the beauty and the terror in that you don't know the right answer.
Yeah.
But that's beautiful as well, because then you get to ask the kids that, well, how do you know your answer is correct? And that's such an important question that we don't usually ask because we know what the answer is supposed to be. So it's just right or wrong and feedback on the method, but that's it. Yeah. You never get the kids to say, how can you be sure that you've got the right answer here? Because I don't know.
Yeah, okay.
And that's really powerful. It's also very confronting sometimes to go, well, I don't know how this assignment's going to go. But it gives the kids an opportunity to find something new, and they might actually make real discoveries. Occasionally you see something in the news about a kid who's discovered a planet or a star, or,
which
someone
is only
who's
recently.
Yeah, there's been a few. Someone who's done something new and found something that people didn't know about. With data science, that opportunity exists in almost every project because there is so much data out there that has just never been analysed. And if the kids are finding their own path through it and asking their own questions, which is a big part of what we teach, how do you know what questions this data set can answer? Then they may well come up with something new. And that's amazing to the kids to think, oh, I'm not doing something that 15 million kids have done before me, and that, my kids both did materials in year 7, and everybody in materials in their first assignment, they build a box.
Yeah. It's amazing to think of, though, because really we want our students to be critical and creative thinkers and problem solvers, all those really important 21st century learning skills. And essentially that's what's happening with data science, isn't it?
That's exactly right. Yeah. I had a bit of a revelation last year, which was that this is the antithesis of the way we teach science at the moment. And the way we teach science is a real problem, because what we do is we get the kids to do experiments where we know and they know what the outcome is supposed to be. So if they don't get the results they expected, what do? They fake it.
Yeah.
They copy their neighbour's results, or they write the results it should have been, and they draw a nice straight line if they were expecting a nice straight line or a nice curve, and then they, work out what the data should have been. We are teaching them to fake their work. That's terrible.
Yeah.
If you think about it. Why are we not giving them more experiments where we don't know the outcome, and we need to test whether the outcome we actually think we found is the right one? And how can we do that? Having that whole conversation. Kids need to meet uncertainty.
Yeah, yeah. And that kind of leads into my next question, which was thinking about data science. So what would be the biggest issues in data science being taken up in Australian schools?
I'm not seeing a lot of issues being taken up yet, but there are a few recurring themes that I really love, and one of them is the Sustainable Development Goals.
Yeah,
they're a big theme, and I think that's incredibly important. Really good to get kids exploring those issues. I do have some reservations about that, because often you'll find that what schools do with that is they do a toy problem. They say, how could you fix this? And then the solution the kids come up with is never implemented. It's never tested. It's like, what could you do if you could tackle water shortages in Africa? And it's all very hypothetical, and the kids have no agency, no ability to actually create change, which is why I like the local ones, where you actually find a problem in your own community and measure it and try to fix it, and then measure it again to see if what you did worked.
Okay.
that's got all the aspects of you basically building a science experiment there, but you're also analyzing the data and communicating the data, and it's got all that stuff in it. But the kids know why they're doing it, and they're doing it because they want to fix something.
Okay.
Anything from litter to traffic to access to the basketball courts to it's just what the kids care about.
So where can kids get that sort of data?
Well,
if they're looking at their local community,
they collect it themselves.
Okay.
So it's about surveying the community, or it's about actually standing around for an hour to see who's using the basketball court. Is it the same two kids every time, or is there, is there a system where people can get a turn? Are there people who are missing out? That stuff, that's observational data that you can collect. And then in that process, the kids are learning rigorous ways of collecting and recording the data as well.
Yeah.
The other things that are coming up are sort of themes that you see in the media. So when War on Waste was out, there were a lot of litter projects, which is awesome. So the kids are learning about where the litter goes and what most of the litter is, but then put that in local context. Actually collect all of the litter in your school, or if it's too big in a section of your school, and go through it. What is it? Is it all cling wrap from home, or is it Isopol wrappers, chip packets, cans? What is it? And okay, now that we know what it is, can we find some ways of dealing with it? Like if all of the litter is in one particular corner of the playground, do we put a bin there? Would that solve it? How much of it is recyclable? How much of it is actually getting recycled? Just kind of actually looking at the issue.
And their problems, especially young kids, will find joy in trying to solve. I mean, we see it already now, students trying to solve the waste problems at schools. But I think doing it that way, as you've suggested, is probably a lot more meaningful for them as well. But I guess that's a problem that even adults can do the same thing to try and solve it in their community, isn't it?
Absolutely. And one of the really important aspects of it is that they then measure it again to see if it worked, actually testing their solution. And finding out, well, did this have impact? Because I'm sure you've seen it in schools. I certainly have, and in universities and in workplaces where the organisation brings in some grand new process, or they've drunk the Kool-Aid on a new idea. They bring it in. Everybody implements it with great enthusiasm, and the next thing we know, we're implementing the next one. Nobody's actually gone back and gone, did that work? And, governments do the same thing. They make sweeping policy changes, they make laws, but nobody's actually evaluating them to see the impact.
It's almost a waste of a time when you're not doing that, isn't it?
Exactly, because you have no idea whether it worked or not. Let's keep the ones that work and throw out the ones that don't. We can't do that unless we've tested them.
Yeah, absolutely. So what's one thing that teachers can do to get the ball rolling with good data science?
So step one would be grab a lesson plan and try and implement it. It's incredibly important, I think, to connect with other teachers who are working in this space. So that's something that ADSI is going to introduce fairly shortly, is a teacher network so that teachers can actually support each other in this work.
Yeah,
it can't all be about me. To grab a lesson plan and start working with it. But also, if you have cool data projects of your own, contribute them back. We can pop them on the ADSI website. Once we've got the community up and running, you can pop them in the community and, share stuff. Take what someone else has done, adapt it, share it back, actually build a community repository of projects. I think that's going to be really important.
Yeah. And I think community building is important. And we're lucky that we live in an age where we can tap into teachers from around the world who are doing amazing things. And like Linda said as well, you can send them to ADSI to put on their websites. And I know I've done a little bit with you in the past, sort of trying to help out and put a primary teacher's lens on things as well. So
that's so powerful and so useful.
Yeah. And I know from my point of view, I think a lot of people would be scared to delve into something that they think is so complex, when really, I think you've already talked a bit about it. The kids are doing all the work.
Yep.
It's really about the teachers stepping back and giving those students agency over what they're doing.
Yeah.
And you're just asking the right questions and leading them down the path that, you think that they should be on.
That's exactly right. And it's all about sort of just understanding the basic scaffolding that that the right questions to ask the kids and the right tools to point them at. And that's some of the stuff we teach in our workshops. It's also on the website. CSIRO has an educational data sets project which I worked on last year. And they've got a bunch of really cool and useful resources on their website as well. So that's worth looking up. There are links to that on the ADSE site if you can't find it. But if you just search CSIRO educational data sets, you'll find it. There's some really cool projects there and really cool resources that'll help you just, I think once you've run one, you get the hang of it and then see that it's not so terrifying. It's really achievable. I'm not getting you to do machine learning and, crazy levels of Python code. Most of what I teach is spreadsheet stuff.
Yeah. Okay.
Or at the lower levels, the kids are doing data representation by stacking blocks.
Yeah. Excellent. So what is the ADSE website again?
It's just adsei.org.
Easy to find.
Yep.
All right. So that sort of wraps it up for us. So thanks so much, Linda, for being part of the show today. If you have any questions for Linda or I, you can email them to me at dan@ponderingdan.com. And remember, you can get in touch with Linda at DataSciAU or at Linda McIver on Twitter. And of course on the website, which is adsei.org. And remember to leave a review for the podcast. It'll really help it grow. And until next time, I'm Danny. And thank you again, Linda.
Thanks so much for having me on. That was awesome.
Bye.